Hello. In this video, we're going to work through this problem here. And like all these problems, it's so important to draw a picture. Let's dive in. A television screen is 40 centimeters high and 60 centimeters wide. The picture is compressed to 62.5% of its original area, leaving a uniform dark strip around the outside. What are the dimensions of the reduced picture? Now this problem is a pretty standard problem that we see when we're learning about quadratic word problems. And the reason I say that is because it has this type of diagram set up. So if we think of this as the TV that I've just drawn, what I know is that it's 40 centimeters tall and 60 centimeters wide. So this is my television. What the problem is stating is that the actual image is inside, is compressed. So the actual picture image is inside of here. And what we know is that the area of the picture is 62.5% of entire screen. The setup here, the piece that's really important to help us get through this, is the idea that this strip around the screen is uniform. So since this is uniform, what I know is that the distance from the tip of my picture to the tip of the screen is the same all the way around. So it's x, 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 x. And of course, we really only have to draw this for one corner, but this illustrates the idea that if this is the picture in the center, there's a uniform strip all the way around the outside. Again, this is a pretty standard problem. Often you'll see problems where there's a grass field and then someone's cutting the field from the outside in a rectangular pattern. So the first thing is we want to do with this problem is we want to find the area of the picture. So what is the actual area of the picture? Well, if the area of the TV screen is going to be 60 times 40, that's the area of the TV screen, and we know that the area of the picture is 62.5%, we can multiply that by 0.625 to find the area. So area, and we'll just pop up my calculator here, clear that up. 60 or 40 times 60 times 0.625, and we get 1500. Okay, so we know the actual area is 1500. Now what we want to do is, since we're solving for x here, we want to find what is the area in terms of x. So if we know the outer edge here is 40, the question is, well, what is this from here to here? And this is going to be 40 minus 2x. So that means we're going to see 40 minus 2x. Right? That's the distance from here to here. And the distance from here to here for the picture is going to be 60 minus 2x. And that's going to equal 1500. And now I have a quadratic I can solve. So it looks like it's factored, but the problem here is that the one side isn't 0. So we're going to expand this and then get everything to one side and go through our factoring process. So 40 times 60 is going to be 2,400. And then minus 80x minus 120x plus 4x squared is equal to 150. Sorry, not 150. So now let's divide everything by 4. So this is going to give me 600 minus 20x minus 30x plus x squared, and then 1500 divided by 4. Again, if you do that in your head, but it's sometimes quick to pull up your calculator, so we get 375. So now let's get everything to one side. So I'm going to have x squared minus 50x plus 225 equals 0. So now I want to factor this to solve for x. Lots of ways to do this. If I'm not sure, I could use quadratic formula, but I'm probably just going to take, if I notice here, let's talk about observations first. It's going to be x and x, and if it's two numbers that multiply to give me a positive but add to give me a negative, they both have to be negative. So I'm going to start guessing numbers less than 50. So let's take 225 divided by 40, doesn't work. 225 divided by 45, and look at that. So we have x is minus 45, and x is minus 5. So therefore, x is equal to 45, and x is equal to 5. Okay? So if we now know what x is, we can find the dimensions of the picture. So for case 1, the length is going to be 60 minus 2 times 45, and that's going to give me 60 minus 90, which equals minus 30, which doesn't make sense. So this is one of those situations that we watch for where we get a negative length and we just ignore it. So x equals 45 is invalid. So now we take case 2. So length is going to be 60 minus 2 times 5, which is 50. That's fine. Width is equal to 40 minus 2 times 5, which is 30, and that's perfect. So therefore, the dimensions are 50 by 30. And we're done. So again, this is actually a really good question to highlight, because this idea of having a standard width around some rectangular shape is a pretty common type of problem. I hope this video helped.